So welcome everyone to the Solar Decathlon Design Challenge semifinals for the Retrofit Housing Division. My name is Marley. I'm going to be your jury coordinator. I'm a mechanical engineer at NREL, and I'm joined by Audrey here, who's our jury assistant. She is also going to be helping out with this. She's kind of the behind the scenes timekeeper person, and I'll kind of be moderating the presentations and Q&A session. So just gonna go through some high level things at the beginning and reminders, and then we'll get started at 12:10 with the first presentation. So just as a reminder of the schedule, we've got presentations today for about 4 hours. We have 5 teams that are going to be presenting today, and then we've got an additional few teams going tomorrow. And then after that, we'll have our jury deliberate. And then at 2 p.m. tomorrow is when the finalists will be announced. So make sure to attend that so you can see who's moving forward to the finals. Just some housekeeping items. You guys probably have done Zoom a million times by now, but stay off of video and on mute when you're not presenting, just so we can highlight the people who are presenting at that time. And we'll also try to spotlight their videos so that you can see the presenters. Another reminder, you'll get 8 minutes for your presentation and then a 5-minute Q&A period. We're going to be timekeeping here. And so the way that we'll let you know that you're almost done is Audrey is going to be changing her Zoom background to say 2 minutes. And then when the time is up, she'll change it to say time's up. So we'll make sure to have her video spotlighted so you can always see how much time you have left. So here's kind of an example of how that's going to work. But just be aware of your time. And if you go, over time, I'll have to cut you off. But I'm sure you guys have all practiced perfectly now, so you should be good. And then we'll have the 5 minutes of Q&A. So we'll probably have time for 1 to 2 questions per juror. And try to keep your answers brief so that you can get to as many questions as possible. And finally, you can use the chat box for if you're having technical issues or anything. Audrey will be monitoring the chat the whole time. So I want to introduce our 2 jurors for the Retrofit Housing Division. We've got Michael and Stephen here. You can see their Zoom backgrounds have the little blue box that says juror. So they're going to be here the whole time watching your presentations and asking questions. So I'm going to read some bios for them real quick so you can understand their background and where they're coming from. So first we've got Michael Ihesiaba. He is the Director of Engineering at Elevate, a nonprofit organization that designs and implements programs that reduce costs, protect people and the environment, and ensure the benefits of the clean energy economy reach those who need them most. In this role, Michael leads Elevate's engineering team in supporting the organization's engineering and technical expertise needs. The engineering team conducts energy assessments, conducts energy modeling, and provides technical consulting for Elevate's programs, projects, and utility programs that deliver services to a wide range of buildings, including commercial, nonprofit, multifamily, and public buildings. Prior to joining Elevate, Michael held senior roles within the energy efficiency and sustainability sectors for consulting companies and utilities Consolidated Edison, New York, and National Grid, New York. Michael holds a Bachelor of Science degree in Mechanical Engineering from the Grove School of Engineering in New York, and an MBA from the Neil Griffin College of Business in Arkansas. And we have Stephen Wilder. Stephen Michael Wilder is an architect and entrepreneur from Harlem, New York, with 20 years of experience working in the built environment. Stephen is a very ambitious person who is rooted in creativity and the desire to be innovative in new and existing spaces. Stephen is dedicated to using his status, resources, and influence to better his community and other similar communities. For the last 10 years, Stephen has worked on building his architectural firm, Think Wilder Architecture. In the competitive and detail-oriented industry of architecture, there is not a day where Stephen is not juggling business, creativity, and technology. Stephen plans to use his business and architecture as a platform to help change the way underserved people live, work, and play. He has professional affiliations with the National Organization of Minority Architects, or NOMA, and the American Institute of Architects, AIA. Stephen has a master's degree in science of architecture from Carnegie Mellon University and a bachelor's degree in architecture from Howard University. All right, and finally, we just want to thank all of our Solar Decathlon sponsors, which are pictured here. And with that, we've got 1 minute until we start our first presentation, which is Ferris State University. So I'm gonna stop sharing my screen, and then the students from Ferris State can come off mute and share their screen, and then we'll go ahead and get started whenever you guys are ready.
All right, just share our screen here.
Okay. Okay.
All right.
So whenever you guys are ready, we'll start the timer. And as a reminder, you'll see the 2 minute, 2 minutes left warning from Audrey.
All right.
Awesome.
Ready?
Ready.
Ready.
Hi, we are Solar Society from Ferris State University, and we'll be entering the Elm residence into the Retrofit Housing Division.
Electrified, livable, modern.
Hi, I'm Brianna Weekman. I am our team lead, and on my team, I also have Austin Andrews, Quinn Howard, Jack Lacouture, and Ben Smith. Our faculty advisor is Chris Cosper.
Welcome to the Elm residence. Built in 1910, this house is over 100 years old, which means that it has been through a lot of our history. And moving forward, we want to make sure that we recognize that history, even though it doesn't necessarily have any inherent historical value. As we seek to improve the home, we want to recognize and honor that history of the house and all that it's been through. We want to electrify this house with a touch of modern technology while making it livable through minimally invasive changes that honor its roots. We want to bring this house into the modern world to keep it relevant in our fast-paced, ever-changing society. Our biggest goal with the Elm residence is to inspire the community of Big Rapids to engage in similar retrofitting projects with their own homes. We want to show them that retrofits are a sustainable way to make a net zero home while also being economically accessible for everyone. For our home, we want to ensure that our modifications are more of a natural evolution than a complete overhaul. And we also would really like to improve the circulation and space planning to increase efficiency and better fit the present needs.
So if we look at the target market for Big Rapids, I'd like to direct your attention to the graph below. Representing Big Rapids is red and the rest of the United States will be gray. If you look, you can see that around 50K for median household income is where Big Rapids will begin to lag behind. For this, we are introducing a tiered package system. At the first level will be bronze, which is just an improved HVAC system with installation improvements. Our silver tier will be introducing net zero into the house with PV, and gold will finally be a fully integrated smart home. We are looking to target individuals and families who make less than national income, groups of people who are not familiar with sustainability, the next generation, not just activists, but ordinary people, older landholders who have land to utilize that PV to its fullest potential, as well as aspiring college students who have sustainability in mind when looking for colleges. And looking at the local climate conditions for Big Rapids, we can see that it is a temperate continental climate. This means that the average temperatures towards the end of January will be 13 degrees Fahrenheit with an average high of 81 degrees around the middle of July. And due to its geographic position, Big Rapids will tend to have cooler temperatures due to it being more northern in Michigan. And on average, Big Rapids will see roughly 11 hours of daylight, approximately 4 of which will be peak throughout the entire year. This coincides with our climate-related strategies, which is to improve building insulation and installing modern windows to improve that insulation and reduce that air leakage.
So Big Rapid follows the 2015 Michigan Residential Code, which is based off of the 2015 International Residential Code. When entering into the home, we noticed that there were some code deficiencies in the upstairs bathroom. And so moving on into the future of the project, we would like to eliminate those code deficiencies. Big Rapids falls under Climate 6 Zone A of Michigan, and in the table, those are the minimum R values that are required. And so we will be working to exceed those into the future.
And looking at our plan for the final submission, I did indicate with colors that gray is what we have done to date. Red will be our fixed deadlines, and green will be more of a flexible guideline for us to follow. So what we have done today is we have photographed existing conditions, we have as-built measurements, we also have included thermal images, heat flux sensor data to get R values of our walls, as well as use Cove tool to get a baseline EUI and a baseline HERS rating. If we look to the right under that first green, that's where we're going to interpret all of our data. We're going to document our findings as well as begin preliminary design work. Moving away to the bottom half of the graph under the green and to the left, that's where we're going to finalize our package system, work out all the finer details of that, finalize all of our supplemental data, as well as finishing up our designs to ensure that they are up to our standards, leading us to submitting everything, leading us right up into finals.
Yeah, so the contest discussions outline the goals that we plan to achieve throughout this project. Within architecture, we'll be honoring the history of the home while improving it to net zero. For engineering, we'll be making the changes to a heat pump, LED lighting, and switching the home from its current gas systems to electric systems to allow for PV in the future. For market analysis, we're focusing on those homeowners of Big Rapids and how they can achieve net zero. As Austin mentioned, we do have a couple different socioeconomic statuses in our area, and to reach those, we'll be using that tiered package system in differing price ranges. For durability and resilience, the Solar Society will improve the insulation and gutters for the long, cold winters here in Michigan. We'll also be adding batteries to prepare for potential power outages. Within embodied environmental impact, we're retrofitting an existing home, so we'll keep that impact low from the start. And along the way, we'll be using Cove tool to help us measure the impact of our renovations. For integrating the performance, we'll be integrating more efficient systems such as electric ground source heat pump, improved windows, LED lighting, earth tunneling, as well as PV. Within the occupant experience, the experience kind of isn't that great right now because the house is a little outdated. So we'll be bringing in new updated appliances, better lighting, and removing that outdated wallpaper to update the spaces. For comfort and environmental quality, the current home struggles to keep that heat in, so the upgrades to insulation as well as windows will help us combat that. For energy performance, we have energy modeling through Cove tool as well as Ecotrope that has helped us develop our baseline HERS score. And this rating will help guide us through passive as well as active strategies before we make that leap to PV.
For some additional information, we've included multiple images on the right-hand side. The first of which is our thermal images showing heat loss through both the windows and the walls of the building. The second is our sun path chart to show the proper orientation of PV panels that we hope to be adding in the future. We also have existing conditions, which are documents that we have and what we wish to do in the future. We have heat flux sensor data to determine just how much energy is infiltrating and exiting the house through the envelope. We have as-built drawings, which is a Revit model that shows the current floor plan along with window and door orientations. We also included Cove tool and Ecotrope Insight data to establish and display embodied carbon and HVAC energy performance. In summary, the Elm residence has stood for over 100 years. Through the use of passive systems, sustainable practice, and minimally invasive improvements, we seek to usher the Elm residence into a new era. For us to build a sustainable future, we must first renovate our past, and the Elm residence is the perfect forerunner for this endeavor.
We are the Solar Society, and this is the Elm residence.
Thank you.
All right, thank you guys, right on time. So now we'll get into the Q&A session. You guys are welcome to refer to your slides throughout the Q&A. So feel free to keep sharing those if you wish. But I'll start out with Michael.
Sure. Thank you, Molly. And great presentation. Thank you for your time. My first question is, you mentioned that you're looking at different folks at different income levels. Did you do any sort of utility assessment of bills for the Elm residents? And did you look into the potential rate design for when you eventually electrify?
Yeah, so we have just obtained the bills from the homeowners. Just recently, it took them a little bit of time to get those in, so we weren't able to include those in our semifinal presentation. But going forward, we'll be looking more into that and how those numbers and data, how we can improve that, as well as make it easier for people on the lower income side.
Awesome. That's it for me. Thank you.
Stephen, go ahead. You're on mute.
No matter how many times I do this. Thank you guys. Happy to be here. Great presentation. I realized the time went really fast, so I'm sure there's a lot of information you guys would like to have. So I have kind of like a general question in terms of when you're doing your cost analysis and in all types of renovation projects, especially for single family homeowners, budget is a concern. So have you guys prioritized which improvements you would like to make, and have you considered a strategy for phasing the work of retrofitting the home?
Yeah, so that's why we introduced that tiered package system. It was a way for us to kind of break the mold for the socioeconomic climate of Big Rapids. Baseline would be the bronze, which is just an improved insulation and an HVAC system, making it a little bit cheaper for folks. And for folks who make a little bit more, potentially professors out of the university, they could introduce net zero into their house, leading us to the final package, which would be a fully integrated smart home. All these individual pieces aren't necessary to be for the houses, but it is a way to guide folks into sustainability while seeing that the cost can be relatively low.
Okay, thank you.
So I'll just leave it open for the jurors now. Feel free to ask additional questions. We've got a few minutes left, so want to utilize the full 5 minutes.
And can you guys talk more about you mentioned about making the home efficient from a design standpoint? What are some of the inefficiencies that you've seen, and what are some of the things you're proposing to improve?
Yeah, so in our initial walkthrough, we noticed that the main living space, which is being utilized as a dining room right now, it kind of ties everything together in the house, and it's a really big room. It's extremely awkward. And so we're working to kind of reorganize that space to help better fit with the rest of the house. And then also in the upstairs bathroom, which is the only full bath in the house, the layout is extremely cramped. It doesn't flow very well. The counter, like where the sink is crammed kind of behind the shower. And so we're working to kind of renovate that space to make it easier to comply with building codes and overall just improve the flow of each space so that each space can start to work with each other versus seeming very disconnected from each other.
Okay.
Did you look at anything regarding weatherization of the home, since this is a fairly old home and you are going into electrification, just sort of the steps to weatherize before you actually jump into electrification?
Yes, our faculty advisor, Chris Cosper, had directed us to a home in Ann Arbor, Michigan. I cannot remember the name of the house, but it was a house of similar age. And with that house, they have introduced PV arrays and they had made the house net zero. So we were looking at as a case study to kind of guide us along this journey.
All right, so that concludes our 5 minutes for Ferris State. So I want to thank you guys for your presentation.
And thank you for letting us.
All right, so next up we have the University of Oklahoma. Looks like we've got the team here. I'm actually gonna spotlight the jurors for now. as well as Audrey. Forgot to do that on the last one. Okay. And then I will also spotlight the students who are speaking. If you guys want to start sharing your screen, we'll go ahead and get started in 1 minute is when your presentation is set to start. Okay, it looks like we're running out of spotlights, so.
Hello, can you hear us well?
Yes, we can.
Thank you.
Okay, we can see your screen. However, it's not the full screen view. I'm seeing the PowerPoint view. There we go. Okay, so whenever you guys are ready, we'll start the clock and go ahead and get started.
Do you want to mention whether we are using one mic?
Okay.
Should I start?
Yeah. Yes.
We are the Ecosooners from the Gibbs College of Architecture at the University of Oklahoma, presenting the Paseo Home Gallery. In this presentation, we are going to cover the following topics. This is our team. We are 8 graduate students from the Gibbs College of Architecture. And here are our industry and academic partners. We provided strategic planning through data gathering, mission, vision, and values and goals. We created built environment objectives. Our goal is to meet these codes.
Our site is situated in Oklahoma City's Paseo Art District, located north of downtown. After its establishment in 1929, it hit rock bottom till 70s, but one NGO, Positively Paseo, helped to revamp it. And in 2010, it was added to the National Register of Historic Places. When we researched demographics, we found that majority of the population consists of non-family individuals or single parents. Income is below the national average. Though we all know that renovation is more sustainable compared to the new construction, we wanted to check whether it is economically viable in that neighborhood. For that, we compared the selling prices of available houses in the area, and we found that renovated houses get $60 per square feet more. So affordability is kind of very low, as most of the population is below qualifying income for mortgage. Hence, we decided to design a solution for renting or selling. We focused on sustainability, low energy uses, occupants' well-being, aging in place, thermal and visual comfort, and resilience. But as being located in historic district, along with all these criteria, we have an added criteria of historic preservation. And also being in a low income community, we prioritize keeping the retrofit budget low. So this is the existing house, a 100-year-old house, 2-bed, with a laundry, which is added later on the south side. It's a corner plot right at the entrance of the Paseo Art District.
Some of the key architectural principles considered to enhance the existing building of the Paseo District are aging in place, connection with nature, historic preservation, and social engagement. Our existing plan is a 2 BHK with a square foot of 1301. We demolished the interior walls as illustrated to promote social engagement and movement flow. In response to the site's demand, our suggested concept improves accessibility and historic preservation by constructing an art studio on the northeastern site and enlarging the guest room in the back. The proposed plan's movement flow is depicted here using accessibility as the key design philosophy. Shown here is the accessibility circulation of the proposed plan. We kept the users in mind while designing the space to address the question, who are the users of the space? And these render depict various people utilizing the area in different ways. Users were divided into 6 groups based on the demographics of a site location and how they could utilize the space on a daily and special occasion basis. These are some of the additional renderings representing user interaction. Given the climatic conditions in Oklahoma City, our recommended concept includes a tornado shelter. We also retain the fireplace to illustrate another of our design strategies, preservation. One of the scenarios depicted here is of individual using an art studio. The interior materials were chosen in compliance with LEED, ASTM, and ANSI. We improved the U values more than twice by adding insulation to the walls, attics, and foundation. These are the materials we chose to put in our building envelope to boost efficiency based on the intended U values.
The building structure had been extended in the last century. This is our existing structure. And based on the existing condition and our design, we propose a new structure layout. This is our proposed HVAC layout with no return ducts and efficient placement of supply. And here is a proposed rainwater collection and solar system. We are proposing 19 panels on the southern roof for the maximum gain, which produce approximately 10,000 kilowatts annually. Keeping in mind the occupant experience and visual comfort, shown here is the electrical plan and furniture layout. Also, the products that we use are Energy Star rated.
So we extracted environmental information for Oklahoma City, like global radiation, perception, UTCI, relative humidity, wind speed, and sun pass, and incident radiation each surface receives for potential PV panels implementation. Because the building was unoccupied for a long time, there were uncertainties about the current HVAC system. So we assumed two strategies: gas boiler and electric thermal heater. This monthly charts are with the electric thermostat scenario. The most energy consumption for existing building is in the heating sector. And just by implementing passive strategies, we reduced 56% of energy consumption and $700 in energy cost annually. And by adding active strategies, we reduced 73% of energy consumption and $900 per year. Also, by providing PV panels, we went to net zero and reduced 100% of the existing building's energy consumption, considering the thermostat electric heater scenario. If the existing building uses the gas boiler, EUI would be 102, and the design building's EUI would be 15.4, and carbon emission intensity is 1.19 without PV panels, which equals to almost 1 ton annually. We followed some passive strategies like improving insulation to blown-in cellulose and implementing low E windows, and the EUI improved by 64%. And by adding active strategies, including PV panels, we reached -11 EUI and -6 for CEI, and we got 110% improvement. We used Honeybee, Ladybug Energy Plus, Open Studio for our simulations. And considering the existing condition, by testing 2 different window scenarios, we come up with the most efficient fenestration layout. The results showed improvement of visual and thermal comfort and environmental quality.
With the changes of materials and technology following our strategic plan, roughly $96,000 could be achieved as the return on investment. We found very few subsidies that are offered by the state for sustainable homes, and 2 major pillars for return on investments are energy cost savings and increased probability of renting. Renting out the studio space alone could generate $36,000 over 10 years. And the Paseo Home Gallery is given extra life, with thus meeting our objectives listed. As a team and with the support of OU, we were able to develop this project, and we thank you all so much for listening.
Thank you.
Thank
All
you.
right. Thank you so much, to University of Oklahoma. We will get started with our Q&A. So I'll start with Stephen this time. And as I mentioned before, feel free to refer to your slides if you need to.
Sure.
Hello, great presentation. I wanted to know, could you talk a little bit more about how your new proposed layout improved energy efficiency within the home?
So the energy, if we actually simulated our building in for thermal and visual comfort. And then as you can see in the comfort and environmental quality slide, I will show you right now. Yes, the previous one, the other. Sorry, the comfort and environmental quality. Yes, we actually improved the thermal comfort map and the actually operative temperature, and actually we improved the annual sunlight exposure and by providing the new layout. Yes, this layout, I mean the right one, we are meeting the LEED requirements, which our current new layout would pass the LEED regarding ASE, and we improved thermal comfort for every spaces and every our new actually layout.
Thank you.
Yeah, so great presentation, and a lot of slides move very quickly, so I was trying to understand which ones to ask on. But can you talk a little bit about just your time frame, right? Because you've proposed a lot of changes, a lot of really heavy construction going on. How much time will this location not be in service during construction?
So according to the schedule, so mainly we have not changed any of the main structure, and there are two reasons for that. One is we wanted to keep the renovation budget very low, so that is one reason. We mainly changed just interior walls, and we added one small bedroom at the south side of the a building, which already was kind of present over there, but it was a smaller room, so we just added that room over there. So keeping that in mind, we are targeting somewhere around 12 to 16 weeks to retrofit this house.
And that includes mechanical equipment as well, installs?
Yes, including mechanical. We don't have any return ducts. We just have supply ducts and exhausts.
Does that include potential PV installations?
PV installations?
Yes. Yes, it is.
All right. Thank you.
Sure.
Both jurors, feel free to jump in with additional questions.
Can you guys go back to some of the earlier slides with the layouts? It was hard to see it as you zoom through.
Architecture.
Yeah. Come back.
Yes, that one. Do you want any extra explanation or by detail?
It, like Michael said, it was a lot. So I was trying to focus on some specific things to kind of understand what you guys were doing, because you were doing a lot of things. Something that was interesting was the accessibility, and what was your decision making in the level of accessibility and the importance of it?
Yes, we maintain the accessibility of the users because these residences focused on the elderly building. So we maintain this accessibility for to maintain the elderly perspective actually. So we maintain how it will enter and how it will go through the room and the bathrooms and the outdoor and the indoor movement. So we also maintain this accessibility in the kitchen also, which we need the 5 feet diameter for movement circulation. So we maintain this accessibility.
Okay,
And-
that concludes our
Oh.
5-minute session. Sorry, had to cut you
No
off there.
worries. No worries.
So thank you, University of Oklahoma. Next up, we've got Queen's University. So you guys can stop screen sharing and then we'll get our next team up here.
There we are. Can everyone see the slides?
Yes, we can.
Wonderful. I now have however many 100 hours of Zoom experience, and I still have to ask every time because I don't.
All right. Are there any other presenters that I need to spotlight or just you?
No, I was the only one who could make it today. It's just me.
Okay, sounds good. So whenever you are ready, go ahead and get started.
Wonderful, thank you. So yes, hi everyone. My name is Jared. I'm from Queen's University up here in Kingston in Canada. I'm one of our team directors, and I'm going to be presenting to you today, and I hope you find this our project interesting. So first, a bit of background about our team. So the Queen's Solar Design Team was started by our faculty advisor in 1988, actually originally as the Queen's Solar Vehicle Team. They set a number of records for the longest travel in solar vehicles in Canada, which was quite interesting. And recently we've moved into the space of designing and retrofitting sustainable and efficient infrastructure, as that has just been a lot of the focus for our university research. So this year is the first time we've undertaken a retrofit project, and one of the big things we wanted to do was keep it within our university community. So we actually approached the university directly, and we found the university is having trouble, or at least is finding it more challenging, to be able to house all of the new incoming students with the large increases in enrollment we've seen over the last 5 years. One of the things Queen's University definitely prides itself on is the ability to grant residence to all first years, so that's a challenge they've come up with. Sort of continuing from that, in consulting the university, we identified a residence building that was sort of the best candidate to be retrofitted. It was completed in the mid-20th century, I believe in 1959. It currently houses 121 students, which makes it the second smallest residence building on campus. And it's located on the edge of campus in a semi-residential area. Anyone who's seen Queen's University campus knows that it very quickly bleeds into surrounding Kingston. Ooh, my clicker is not working. There we go. So then in talking with the client, we identified 3 major needs, the first of which was to pursue retrofits and renovation over new construction, just because the cost of new construction is prohibitively high. There's also not a lot of space left for new construction in the campus master plan. Also, sort of decreasing the building's energy footprint through both recovery, generation, and some implementation of new technologies. And that's what really drove our design. So we get to our actual design considerations. We cannot change the lot size. We could not build additional structures, so we had to change what was already there. Geotechnically speaking, this problem we found was simple because the building sits directly on bedrock. Most of Kingston is just limestone bedrock, so there was not a lot that had to be done there. Structurally speaking, the building is masonry concrete core, so we figured jacketing of columns would be sufficient for an additional story. And then finally, we set the goal of having the expansion offset financially within 10 years, in line with some other numbers we found from universities who are developing residence buildings. So our proposed retrofit then involves 3 major changes. The first is the introduction of a 4th story onto the building. We would effectively be copying one of the existing levels, and that would allow us to introduce 41 new single rooms to the building, increasing its capacity over 30%. We would also propose the introduction of photovoltaic arrays on the roof and gray water heat recovery. This would be done, 1, to offset some of the energy costs during peak times of the day, and further to reduce the amount of energy that is being sent into the Kingston water treatment system. And then finally, our campus master plan has an interesting stipulation that all renovation and new development must be heated geothermally, which was an interesting system to do the math for. So we had also figured out that it was quite possible to implement heat pumps and geothermal heating to convert it from its current electric baseboard, because we love 20th century electric baseboards. So here you can see a proposed planned view of the fourth living story. Right now there are 3 living stories. This is what we would be adding as a fourth, and shaded are all of the single rooms we'd be considering. Again, we're not actually changing the footprint of the building itself, just adding a new story. We have some of the lounges and kitchenettes marked, some of the public spaces for studying, but mostly it's still very heavily focused on housing over implementing large recreation spaces. And here we have a planned view of the proposed solar array with the maintenance path on the roof in gray, and then the photovoltaic cells or panels, excuse me, as those little rectangles. This basically works out to being a 72 kilowatt array, and we figured, given the budget that would be available for this project and for the energy costs that could be offset when students are actually living in the building as opposed to the summer months when it's vacant, would be best addressed that way. So in summary, we're proposing the addition of a fourth story, solar arrays, introduction of gray water heat recovery, and then switching the building's main heating system to geothermal heat pumps. We see that that is going to help the client sort of generate additional revenue, will help them more clearly reach their housing targets as certain other buildings are taken offline for renovation in the next few years. And finally, we're also hoping that it can be an example for future residence development. Several generations of residences have come through the last cycles of development here at Queens, and we're hoping that introduction of these new energy-focused technologies will be adopted not only in residence buildings, but across for other academic buildings. Yeah, and thank you so much.
All right, thank you. So we'll get started with our Q&A. So I'll start with Michael, and then you guys feel free to jump in. Have the hang of it now.
All right. Thank you, Jada, for that presentation. I'm sure it must not have been easy to do it by yourself. But my first question is, for the geothermal consideration, did you look into the ease of being able to actually dig through the bedrock that it sits on currently?
Yes, it is certainly more annoying than just silty soil. There are several contractors, and because basically all of this area is limestone bedrock, there are several contractors that do it, of course, at a bit of an increased price, but it has been done. So we figured it's feasible.
Do you know approximately how deep you need to go in for the level of temperatures that you need to reach for the heat pump?
That is something we have looked at. I don't have the number in my mind, though. No, sorry.
Okay, got it. There goes, Stephen.
All right. Great job, Jared. Like the presentation. A few questions. So you mentioned adding another fourth story to address some of the housing issues for the increased enrollment. What consideration did you have for creating more efficient layouts for the floors that already exist versus adding a new floor?
Yeah, it's an excellent question. One of the things we looked at with this project is the university currently operates buildings that have a variety of different layouts. Some of them are just singles, as they would have, as you saw there, and some of them involve 2 singles joined by a bathroom. So there were other layouts available. One of the issues we found is that those new, technically more efficient in terms of path travel or square footage layouts would not fit based on the depth required of the building. They're sort of thinner and longer like lake homes. So it wasn't really possible in the footprint unless we made the hallway like 18 inches wide, which was not a great idea. So those were some of our considerations. And also we had considered a big element of it was cost. So we figured it would be most cost effective to add a new story as opposed to reorganizing elements on 3 floors.
So since you decided to go up 1 floor, why not go up 2 floors or 3 floors? Are there FAR or code issues?
Yeah, so because of where it's located right on the edge of a residential area in Kingston, we start to run into height requirements. And also, structurally speaking, the addition of 2 stories would mean the addition of more structural elements inside, which could interrupt walking space.
Okay, and final question before I send it back to you, Michael. When, obviously, are you anticipating occupants in place for construction, or is this something where the building gets shut down, or is it happening during the summer months? What's your plan for that?
Yeah, that's an interesting question, one we discussed with the client. Given some of the construction sequencing, it would be possible to have partial occupancy of the building. The idea would be ideally to have no occupancy of the building, and after some of the other renovations are completed, it would be taken offline for one academic year and then brought back.
Go ahead, Michael.
Yeah, great question, Stephen. You took your last two questions were my questions. Another question I had then was, when looking at the current HVAC equipment that's in the building, a lot of times some of these buildings are oversized HVAC wise. Did you look into seeing if there was a way to sort of stretch out the usage of the current equipment with the new additions?
That is not something we considered.
Okay. I'll send you my bill.
Were there any consideration of environmental issues, asbestos, lead, not lead, anything of that sort that kind of come into your cost analysis or anything?
Yes, fortunately that building has been assessed, and some of those potentially concerning materials were removed a number of years ago. So that was not a huge concern for this project.
All right, that concludes our Q&A for this session. We now have about an hour and a half break before our next presentation. The next one's going to be at 2:20 Eastern time, and that'll be Marywood University and Johnson College. So you guys are free. You can log off the Zoom or you can stay in the Zoom. We'll keep it running, but feel free to take a break for the next hour and a half, and we'll see you back around 2:10, 2:15.
Wonderful. Thanks, everyone.
Whenever you guys are ready, we can already see your screen. So feel free to get started whenever you're ready.
Welcome, and thank you for allowing us to present today. We are honored to present to you Glacier Jane. Our project is a revitalization of the Mariners unit at Girl Scouts Camp Archibald in Brooklyn Township, Pennsylvania. Here, young Jane Jacobs honed her observation skills, and like Jane, today's Girl Scouts will continue to observe the riparian ecology of Ely Lake and immerse themselves in our new retrofitted living laboratories. My name is Alex, and joining me today are Dean, Tess, Tyler, and Lauren, and we represent the fifth-year architecture students from Marywood University and the Jane Jacobs Collegiate Consortium. We are primarily made up of students, faculty, and staff from Marywood University, as well as Johnson College and Penn State Extension Susquehanna. We are also working with industry partners Richard Pedantry and Greenman Peterson.
Like the first campers in 1920 and Jane Jacobs in 1926, Camp Archibald is where many young girls begin to understand the unique ecology found at the lake, in the woods, and in the camp's community. Our design intention is to preserve and improve water quality of the glacial lake. In 1938, Mariners Unit boasted the first ever floating cabin for the Girl Scouts of America. Today, it includes 3 pontoon platforms, 2 with floating cabins, a separate troop house, latrines, a water station, platform tents, and a campfire circle. Our retrofit design goals are to improve habitat, access, and education within the aquatic and riparian ecologies of Ely Lake for 2 target markets: the Girl Scouts, both Mariners and younger, and off-season renters, many of them being former Scouts.
Located in the Chesapeake Bay watershed, Glacier Jane will serve as a living laboratory for water quality and habitat improvement. Its gardens, planted with native species, are located on the roofs, climbing up the railings, floating in the water, and terraced on the landscape. These plants will integrate with dense lily pads and vegetation, bringing the sunny side of the lake with the surrounding root system of the evergreen forest to filter chronic acid rainfalls and nitrate-laden stormwater runoff.
We will provide universal access to all parts of the Mariners Unit by regrading the steep hillside with 1 to 20 compressed earth paths leading to our code-compliant buildings and an accessible kayak launch, providing opportunities for Scouts of all ages and abilities to participate.
Glacier Jane will also extend the Girl Scouts' focus on combining observation, self-reliance, and harmonious living with hands-on STEM educational activities for K through 12. During the summer, Scouts will experiment with and monitor water quality, hydroponics, vegetative root irrigation, and passive cooling technology. Located in Köppen Climate Zone 6A, a cold and damp environment, the ultra-insulated materials and assemblies used for the floating cabins are marine-grade quality with energy recovery ventilation to handle the indoor humidity. We are reusing about 85% of the original structure from the existing pontoons in new ways, such as decking, metal, lumber, and sheathing. Floating cabins, pontoon decks, and gardens are positioned beyond the riparian zone to minimize the impact of shadowing. New roofs on the floating cabins orient solar panels towards the south and provide openings for stack ventilation, pulling in cool breezes from the water below. Winds sweeping across the lake are harnessed by 3 vertical wind turbines on the troop house porch. In the troop house, a wall of laboratory cabinets will discreetly house, monitor, and display water and energy usage of appliances and systems with 2 modes: Scout mode, a low-tech, hands-on approach, and Renter mode with more amenities.
In the cabins, similar cabinets will also provide Murphy-style bunk beds, each with a porthole to enjoy the nighttime breeze, sounds of frogs and crickets, and communicating with scouts in the other cabin across the way. When the beds are stowed, there is ample floor space, and when needed, tables will fold down from these cabinets. Learning from immersive interactions at camp mirror Jane's own experiences as she described them in the local newspaper. Some of it is woodland, soft, evergreen woods, fragrant with the smell of hemlock and yew, while tiny streams sparkle and dance beneath the branches. The remainder consists of beautiful green fields dotted with yarrow, buttercups, daisies, and dozens of other flowers. In the tall grass are fascinating grasshoppers.
In order to achieve FIAS Plus Zero eligibility with carbon neutral construction, Glacier Jane will renovate the existing buildings at Mariners Unit with ultra-efficient enclosure layers. These enclosures will better insulate our designs to protect from the outdoor conditions. Given its remoteness and regular weather-related grid disruptions, Glacier Jane will be grid independent, generating and storing its own energy. The buildings will function independently to eliminate the need for overhead wires. There will be a large increase in insulation using reclaimed and regenerative materials like mycelium, sheep, and rock wool insulation. Our combined HERS score with on-site renewable energy is -30, and without the renewable energy is 27. We will also take advantage of passive systems and ideas like night flushing, day lighting, and cross and stack ventilation. Grid independence, conservative engineering, and exemplary stormwater management will overcome risks of falling trees, freezing temperatures, and damaged pontoons. Adverse economic events and potential man-made disasters from regional fracking spills and natural gas pipeline leaks are also a concern. However, our mechanical systems will maximize efficiency and usage of electricity on the site. Our project will allow the girls to learn about the camp's water and energy use with a simple control screen interface showing them all the systems involved in the project. The existing troop house needed an upgrade in appliances and the addition of minimal plumbing to allow for kitchen, bathroom, shower, and laundry appliances. All of these systems are unified with task and safety lighting managed in tandem with the ERV system, controlled by a small wall-mounted display meeting EPA's Indoor Air Plus standards for indoor air quality.
Floating cabins will generate energy using PV panels integrated with solar-heated water for the winter to power the ERV systems. Forest buildings will incorporate vertical wind turbines and a closed-loop geothermal exchange with its ERV system. Scouts living on the water will learn about how the forest and native flora can filter storm and gray water. Visual cues in the landscape prompt the girls to follow the sustainable cycle of maintaining and improving water quality. Stormwater is channeled into rain chains and into hydroponic gardens, into water recovery systems, or into filtration garden beds. Dual system composting reduces black water to 0. Retrofitting existing structures with reclaimed and locally sourced materials will minimize our carbon footprint while also reducing the shadow footprint by 1/3, allowing the riparian plants to regenerate and teaching a new generation how to repair our world.
When it comes to market feasibility and analysis, Glacier Jane will cost roughly $1.3 million. This will require $67,000 in mortgage and maintenance costs annually. Currently, the Mariners Unit generates roughly $15,000 per year from its camps. Based on regional comparisons of Airbnb rentals at $900 per night, we could generate $252,000 of additional rental income over 40 weeks of each year. Total annual income generated would equal to $267,000 with an additional $7,500 solar credit in the first year, leaving almost $200,000 annually to be put back into camper subsidies, programming, and additional salaries. From the last 100 years of Camp Archibald's history to the next 100 years with Glacier Jane, we thank you for the time to present today and hope to move forward soon.
All right, thank you so much. Now we'll get into our Q&A. So jurors, you know the drill by now, just go ahead and switch off and we'll get started with our 5 minutes.
All right, I guess I'll go first. Thank you for the presentation. Quick question, did you guys, since this is on the lands of a lake, did you look into potential impacts of climate change and water levels rising or lowering, and what that impact might be on the structures and your project?
So we did look into that. This is a glacial lake, which means that there's very little water coming in and out other than storm water. There's a very small tributary on one side and 2 very small streams that lead into it. On average, the increase of height of the lake just seasonally is less than 2 feet, and that's usually from water and snow melting into it. So there's not a huge concern for that at this specific site.
From the existing development to the what's proposed, what's the increase in square footage of the development?
I would like to say that the increase in square footage, so the main pieces that are new, the easiest way to talk about this, I think, is to break it up into areas. So on the pontoons, in order to reach our ADA accessibility goals, we had to increase them by 3 feet, and they're 40-foot long. So each pontoon gains, is that 120 square feet? And then the basement of the troop house is entirely new, and that is 600 square feet?
Roughly 600 square feet.
Yeah. So that is the increased total of the inhabitable building space.
And what was the thought in terms of impacting natural habitat on land and water?
So we are doing our best in order to create things that are minimally invasive, but also create different areas that will actually help support the ecosystem in the area. So our rain gardens that are filtering the stormwater, those are areas that will be planted with native grasses and native flora and will actually help those species survive and compete with the non-native species in the area. We're taking the same approach with all of our other gardens, so the roof gardens, the floating gardens, and the gardens that climb up the railings. All of these things are places where the girls can actually go to learn about these native plants and what the benefit of them is. And over time, they'll be able to visually see that impact.
And structural integrity and analysis of the new structures, how much thought and have you put into that?
So a lot of the analysis in the structure of the pontoons was broken down into understanding the max weight capacities of each of the pontoons that are existing. So we are reusing the pontoons that exist from the old floating cabins and are rehabbing them into the pontoons that we're using for the new floating cabins. And we broke down our structural analysis by the weight of our materials and understanding the safety buffer of 20% of our additional weight being covered by just one of the pontoons. So knowing that if we had a structural failure from one of the pontoons themselves, we would still be safely floating on the water and can address the issue in a timely manner for the Girl Scouts.
And the structural, the pieces that we've proposed are actually going to greatly improve the structure of the existing, all the existing implements. So the troop house and the pontoons that do currently have houses on them have structural issues, and all of those are addressed by our design, so that these are things that can last another 100 years, when currently that is not the state that they are in.
Okay, thank you.
I think you mentioned this, but I may have missed it. Wastewater, not gray water, but wastewater. What are your considerations for that with the new structure?
So we do not have any black water. We chose composting toilets that are completely self-contained, which means that the girls will be able to very, very safely process any of the stuff that would be considered black water that normally would have to go through sewage treatment. Everything else is gray water. So all of our storm water, any hand washing water, and any shower water gets filtered into our rain gardens to go through a 3-step filter on the landscape before it disperses or it goes into our, we have one small water treatment for the sinks in the basement of the troop house. And all of those things are things that the girls will also be able to see and begin to understand.
All right, that concludes our 5 minutes. So thank you so much to this team. Our next team up is going to be Appalachian State University.
Hello. Hi, all.
Hello. All right, give me a second to spotlight you guys.
All right. Is our screen visible to you guys?
Yes, it is.
Okay. Awesome. All right, we're going to start off here.
All right. Yep, we'll start our 8 minutes and go ahead whenever you're ready.
Hello, jurors. My name is Evan Hutchison, and I am one of the co-design leaders on our team. We are Appalachian State's High Country Goldfinches, and this is our retrofit project. Our team consists of 3 groups. We have the envelope design, mechanical systems, and graphic design. Our timeline begins on January 25th with the team's creation and our first meeting. We started with the client intro and site visit, and then we quickly established our plan, refining it through hours of group meetings and faculty redlining. From here on in, we plan to perfect our proposal to present the best project we can in Golden, Colorado. Our biggest problem is the housing market in Boone, North Carolina. So to understand it better, let's start with our location. Climate Zone 5, which is highlighted on the map for you, is known for its colder climates with average temperatures about 20 degrees. Our town, Boone in Watauga County, is the only land in Climate Zone 5 within North Carolina and the surrounding states, as you can see. So as a small yet populous college town, housing prices are exorbitant. They've almost doubled in less than 4 years and now are just sitting under $500,000. But income remains stagnant. As this graph shows, the difference between housing prices and income is astounding, and things are only getting worse. There's also an abundance of homes that do not meet today's code standard in our area. Many are vacation homes and rentals that were built over 50 years ago. And from these issues, we built our concept, the birdhouse. We want to wrap our existing nest in a durable and comfortable structure. These homes are like an investment. We will extend the lifespan, while providing an affordable option to achieve a high-performance home. We want a repeatable system that can be applied to all of these older defunct homes, but we know that every bird is different and they have different needs, and we plan to make our retrofit design individualized based on the needs and desires of those clients. I'm going to pass on to Jonas Scott.
Hi all, my name is Jonas, and I'm the student lead here of the High Country Goldfinches. Now, over the next few minutes, I'm going to take you through our process of taking our concept and turning it into reality. So first, this is our process. We begin by analyzing the existing home conditions. From there, we found a design certification we wanted to use as a jumping off point for all future research and developments. Then we began to brainstorm solutions based on those criteria you see there and propose possible solutions. Meet Sarah Grady, our client, the construction manager for Watauga Habitat for Humanity and an App State alumna. Looking at the existing conditions of her home, we found an envelope seriously lacking in insulation, air sealing, and waterproofing. And these are the main points we want to address going forward. Again, as my counterpart stated, this home was built as a vacation house for the summer months and wasn't designed to be lived in during these colder seasons. And the design shows it. Looking into it, we discovered a HERS of 102 with an EUI of about 75,000 BTUs with an annual energy bill of $1,500. Looking below, these are values taken into account fenestration and thermal bridging. Now, we have a few challenges we'll face here. First, we're a low budget retrofit with our budget being around $60,000 for the whole structure. From there, we have a 6-month wind season, with recent recordings reaching above 50 miles an hour and heading even into 70 miles an hour in recent years. We also have 17% higher rainfall than the North Carolina average and 86% higher snowfall. These issues are all exacerbated by a low drying potential due to the site being densely surrounded by trees. Now let's get into FIAS, the Passive House Standard of the US, and they have a retrofit certification that we felt embodied our high achieving goals. These are the 6 main points that the certification hits on, and over the next minute, I will delve into them. First, we have that electrical. The standard states that 80% of the light fixtures must be Energy Star certified. Luckily, we have a construction manager as our client, and wanting to save money, she already went ahead and switched over most of her light fixtures to Energy Star rated LEDs, hitting that 80% requirement. However, we also need to be EV charger ready. We plan to install a 240-volt breaker to satisfy that requirement. On the HVAC side of things, we decided to implement a ductless mini split system for our air conditioning needs. While the throw from this machine should be able to reach the far side of the space, we'll also be using an ERV to increase efficiency as well as provide means of mechanical ventilation. The location of the interior supply and return registers were also methodically placed. Supply enters the ceiling by the mini split, creating a positive pressure, while the return is in the bedroom, creating a pressure differential across the house. Now, this not only helps in lowering our HER score, but also creates a healthier and more comfortable home environment for the occupants. Third, let's talk about fenestration. Well, now, for this requirement, we need to have triple glazed windows with no thermal bridging. Since we need to move the insulation to the exterior in order to meet our wall R-value goals of about 40, we found an insulated window buck to be the optimal solution to prevent any thermal bridging in the framing. To waterproof the home, we decided to create a continuous wrap of a weather-resistant barrier around the entire structure. In order to do this, we plan to remove the existing eave, rebuild it on the exterior of the insulation. And staying in line with that Joe Stebrick inspiration, we want a rain screen built up by 1x4 pine furring strips to act as both the nailing base for the siding and as the rain screen. Now we've got our 1 ACH 50 goal. Remember, our original ACH 50 was 25, so we're looking at 24 difference there. Will be achieved with that same plan as the waterproof, with a low perm continuous WRB. We will take this air barrier into the crawl space by sealing below the home, and we'll take it into the roof by sealing the attic. Lastly, since we have a 2x4 framing structure, we plan to move our thermal barrier to that exterior of the roof and walls, moving it up from the ceiling and cavities, while also replacing the existing cavity insulation to achieve that grade 1 installation. From these basics ideas, we created our scoring rubric, the Goldfinch score. As you can see, it takes into account all those things mentioned before. Now, here's our few proposals that we plan to investigate and research further. First is a SIP nail-based design with 12.25-inch SIPs on that roof structure and 7.75 on the exterior of the wall. This received a lowly Goldfinch score of 6, namely due to that high embodied carbon count and high retrofit cost. And we knew we could do better, so we kept on pushing. Possibility 2 was a huge improvement, jumping up that Goldfinch score 2 points to a score of 8. Now, with this design used polyisocyanaurate exterior rigid insulation. Now, we like the polyiso for its high R-value density, but want to explore other options due to its drop in insulation value with drop lowering temperatures and its higher embodied carbon count. Now, our third design so far is our favorite and the one we really want to expound on going further. It has a Goldfinch score of 9 due to that low embodied carbon count and lower retrofit cost. It keeps the polyiso on the exterior of the wall, but on the roof, it uses a 2x12 built-up roof structure. These 2x12s are placed 24 inches on center with a dense packed cellulose in those cavities. In summation, Sarah Grady's, our client, Retrofit, stands as a proof of concept that our retrofit system can be part of the solution for Boone's housing crisis. Thank you very much.
All right, thank you so much, App State. And now we'll get into our Q&A. So jurors, whenever you are ready.
Can you guys show the slide of how it looks today, with the surrounding area?
Oh, sure. Yeah, absolutely. So going up here, let me just hop on up. Our site plan, show you. There it is, right there.
So in terms of you guys are you guys receiving a lot of natural daylight?
No, sir. We have that low drying potential in that area just because of how many trees are around this area.
Yeah.
It was built as that vacation home, so it's kind of meant to be deep in the woods. And so because of that, we're dealing with a lot of these issues.
Okay. And are the homes that you spoke about in the beginning that have similar issues, are they in similar areas throughout?
Yes, sir.
Yes.
So they are facing.
I mean, this is a pretty mountainous area, so a lot of our area is very wooded and mountainous. So it's a lot of the same conditions, especially with the rain and such.
Okay. Michael, you can jump in.
Thanks, Stephen. And a good presentation. Again, you guys are doing a great job today. You mentioned that this was originally built to be a vacation home and is now being used year-round. Did you talk about what type of heating systems they are using, since obviously it's, it was only meant to be in the summer and now they're going through winter, and how much heating is potentially needed year-round?
Yeah, absolutely. So the existing conditions, I'll talk about right here. So as so many of the houses in this areas are all the same, they don't actually have cooling systems. Again, it's really temperate here in the summers. Our average high is like 75 degrees. So they really only have a heating system, which are electric resistive base plate heat, electric resistive baseboard heating systems.
Mm-hmm.
So to hit the all year requirements, we're switching over to that HVAC system with a mini split.
So go
About
ahead.
that further, we do have our sustainable building system specialist here if you would like to hear more about the HVAC system.
Are there noticeable differences as you're looking into it with heating degree days and cooling degree days? And you said that there's passive cooling, but as folks start to live there full time, have you noticed or have you heard of any need for an actual cooling system?
A natural cooling system. Well, again, because
Not
of the,
natural, an actual cooling system instead of yeah.
Sorry. Yeah. Would you like to talk about that real quick?
Mini split?
Yeah.
Sure.
So we're talking about that actual cooling system. So here with us, we have our SBS director here.
How you doing? Yeah, so we want the 12,000 BTU mini split right above the exterior door. Kind of works with the ERV. The ERV supplies the mini split with fresh outdoor air that is either transferred from the indoor cold air or indoor warm air, depending on the season. And we're dumping that over the mini split. We're kind of supplying fresh air throughout the entire house. That's the entire plan.
Great, thank you. No more questions.
So you guys plan on having multiple air handling units on the interior, or is there just one?
We have one interior air handling unit, which is a mini split located right above the front door. We also have an outdoor condenser that works with the mini split. Yeah.
Okay.
That's suffices because of the small square footage of the house. Again, this house is only like 700 square foot.
We've got time for one more quick question if anyone has one.
Is there any way that you plan on leveraging the fact, because you mentioned being in a wooded area, and you typically mention that as being somewhat of a challenge. Is there any way to use the fact that the house is in that location as a positive?
Yeah, absolutely. So again, in those summer months, we've got that low heat, but also that shade makes it a really, really nice, breezy place. And so looking through those windows, we're going to expound further on using some of those passive solar techniques and utilizing passive ventilation as we move further through that competition.
And if I could very quickly,
We've got to stick to the time, but thank you, App State.
Thank y'all very much.
Thank you so much.
Good,
Sorry, I had to
good
cut you off.
job, guys.
All right, so that concludes our presentations for today. So you guys are free to go now. Tomorrow we've got 2 more presentations. The first one starting at 10:10 a.m. Eastern time. So we recommend you log in around 10 a.m. to watch that. And yeah, that's all for today. Jurors, remember to go and make some comments and record your initial scores. And we will see everyone tomorrow.